Thanks everyone for coming. There will be a panel discussion at the end where you can ask some questions, but I will ask you some questions and get those in first, so don't be surprised when it comes up. Okay, mosquito-borne disease is a huge problem. You probably heard of malaria. We have some success against that, so deaths down from about 2 million a year to about 1 million a year, mostly children under 10 in sub-Saharan Africa. It's far from the only mosquito-borne disease. Another quite well-known one is dengue, close to 400 million infections a year, and those are increasing over time as the mosquito spreads, and we have limited ways to deal with this. So this is about how can we deal with these sort of diseases. This is a 10-year-old quote from World Health Organization. These are incredibly widespread diseases. Something like 17% of all human infectious disease is spread by vectors, so that's ticks and mosquitoes, things like that, of which the overwhelming majority is by mosquitoes. When you think about pandemics, with which we are now much more familiar than we were a few years ago, we think of COVID transmitted from human to human, either directly by coughs and these kinds of things, or through something indirect like contact with the surface and on. But these mosquito-borne diseases, so if I'm infected, you are all safe, unless I'm bitten by a mosquito, the pathogen replicates in that mosquito and then later bites one of you. And that, of course, that's a strength of disease, that it can spread through the mosquito, but it's also a disadvantage because we can do things to the mosquito to block it that don't require either me or you taking drugs, vaccines, or any other particular precaution. What do we actually do at the moment? Well, this is the poison of the title. We try to kill the mosquitoes. And this is trying to control the dengue mosquito, day-biting mosquito. So bed nets, which you're probably familiar with for malaria, don't protect against this day-biting mosquito, albeit very effective for malaria. So what we do instead is down on the left here, we try to find their larvae. So mosquitoes breed in water. And so used tires and these sorts of human-derived, for this mosquito, these sort of human-derived small water pools. And this is an inspector, but you could also exhort the citizens to clean up these breeding sites. But if you think about your property after a rainstorm, how many separate little pools of water are there, including blocked rainwater gutters, underground drains, and these sort of things? And if you were to go around and treat every one of those every week forever, in a tropical city where this mosquito lives, then you could stop this mosquito breeding on your property. But if one person on your city block didn't do that, that could produce enough mosquitoes to infect everybody anyhow. So although on a sort of local scale this is rather effective, of course you can kill the mosquitoes this way if you find them, it's very hard to do it rigorously enough to actually prevent transmission. So this is trying to control the larvae, these little wiggling things that live in water, and the more familiar adult form of the mosquito we can try to kill with this sort of approach. This is fogging. So this is an aerosol toxicant. You're trying to fill the entire volume of the environment with a toxicant aerosol, which is not a very environmentally friendly approach. It's also not very effective because these mosquitoes hang out in still air where these sort of sprays don't penetrate. It is very visible, so this is your government doing something, but the something, unfortunately, is not particularly effective. Okay, so this is the current state-of-the-art for control of the mosquito that transmits dengue. And also, dengue's been around a long time, but we also have epidemics, and again, people are much more familiar with the concept of bad epidemics than they were. Zika and chikungunya are big epidemics of this century that have spread around the world in tropical and subtropical areas transmitted by this mosquito. Okay, so if we're not going to just try to poison them like that, what could we do? And this is the sex part, which, as Zana said, is not quite as exciting as the title may have indicated. But anyway, so mosquito reproductive biology in cartoon form. Boy meets girl, sing little songs to each other, which they really do, and in the normal way of things, you get lots of little baby mosquitoes, and so the population continues and expands. And this is about the level of technical detail we're going to get to. But what if we released males, and I should point out that only female mosquitoes bite, males don't, so if you release lots of males, they won't bite anybody, they'll just go and look for females to court and mate. So if you had some heritable modification in this mosquito that was then going to be inherited by the next generation in the wild, you could change the properties of the wild population in a targeted way to the extent that you can modify that. So then if you were going to have some sort of heritable modification going through to the next population, what would it be? If you could modify the disease-transmitting mosquito population, how would you like to change it?
The offspring to be sterile.
Pretty sterile, okay. Absolutely. So there's one category where we say, what if we could do something that would make these die or be sterile or just less able to reproduce? And then if we can get enough of the females to mate, to inherit that trait, the target population will decline and collapse. And that's absolutely one sort of approach. It's actually what I spent 10 or 20 years doing. So I very much approve of that answer. Anything else? Sorry? Right. So another possibility is say, what if you could make them, this was eat fruit, but not bite people? Okay? Bite something else. And in fact, most mosquitoes are not that keen on biting humans. There's 3,500, more than 3,500 named species of mosquito, most of which will bite birds or reptiles or larger animals or not particularly keen on biting humans. It's the ones that bite humans that are particularly good at transmitting human-specific diseases, and there aren't that many of them. If we could modify them so they chose to bite something other than humans, they would now be much less able to transmit human-specific diseases because they weren't biting humans very much. The trouble with that as a target for modification is we don't actually know how to do that. So it's clearly, some species prefer to bite humans, some don't. It's clearly a genetically encoded heritable trait, but we don't really understand the basis of it well enough to change it. We can sort of destroy their sense of smell so they can't tell one thing from another, but that's a bit unsophisticated. We can't say, oh, actually, maybe you'd like to bite birds instead of humans. We don't know how to do that. So it's a good idea, but it's beyond our capability at the moment. Anything else?
Make them less likely to carry the parasite.
Absolutely. So both of you had the same answer, and it absolutely. So what if we could make them less able to transmit the diseases that we care about? They still be there, still filling their ecological niche to the extent they have one, still biting people, but not transmitting the disease because they, let's say, can't become infected, they're resistant to it. Absolutely. So these are two of those three. These are the two we can do and not the one that we can't do of trying to make them bite something other than humans. So and the outcomes are a little different. I'll talk about that a little more in the end, but the result of both is that those mosquitoes are less able to transmit. And the features of this sort of approach compared with more conventional insecticides are quite significantly different. So the first one is extremely species specific. The males that you release will only make females of their own species and nothing else. So not only will they not affect bees and butterflies and other such insects in the environment, they won't even affect other species of mosquitoes, so just the ones you're targeting, which make far to a much greater extent than any kind of chemical insecticide or whatever ever would. The males are really, really good at chasing females and finding the females and finding them in hard-to-reach populations or small populations, much, again, better than human inspectors or chemical sprays. Another feature is that this is area-wide. You release these males, and they will fly over an area, and everybody in an urban area, that might be a lot of people. So it also means that you think, what does it cost to treat an area? In an urban area, that might be a large number of people. In a rural area, less so, which points to more useful in some areas than others. But also, everybody in that area is equally protected, irrespective of their wealth or education or any other particular characteristics. So it's a very sort of equitable approach within this area compared with individual treatments like vaccines and medicines where access might vary a lot depending on the nature of the person. Okay, so just in a teeny bit more detail, I'll run through this quite quickly. There's population suppression. This is putting out sterility, lethality traits, that kind of thing, which is also the same intended outcome as sprays and whatever. Just have fewer. If there are fewer mosquitoes, there are fewer mosquitoes to bite and less transmission because there are fewer mosquitoes. Where you have something like the main mosquito I work on, Aedes aegypti, transmits yellow fever and dengue and Zika and chikungunya and a bunch of other things, this will prevent transmission by all of them. And it is native to part of Africa, but it's been inadvertently spread around the world by humans. So most of the places you think of dengue, South America, Southeast Asia, it's an alien invasive species, and maybe the gold standard would be actually to be to remove it if we could, and the ultimate goal of a population suppression might be that. On the other hand, if you remove it, maybe you're leaving an empty ecological niche that something else could invade. On the other side, so the population modification is sort of everything else. So what if we could change them to be less able to transmit the pathogen, or indeed to bite something other than humans and so on? So it's harder to explain to people what you're trying to do there. So mosquitoes are still there, but and still biting. You have to persuade people that they're less able to transmit. There's not really an equivalent to this. It is actually very similar to what if you could vaccinate the mosquito population. Okay, so if they were vaccinated, then they would be resistant. They'd bite a person, but they wouldn't become infected because you vaccinated them, and so they wouldn't transmit the disease because you vaccinated them. Of course, there are all sorts of reasons why we can't vaccinate mosquitoes, but if you could, the outcome would look quite a lot like this. And if you had a mosquito that you thought was an important part of your ecosystem rather than an alien invasive one, you might prefer to do that. So not remove it, it's still there, it's still filling its ecological role, still biting people, but not transmitting the disease. So this might be preferable. If we could do any of these things, which would you prefer? So first of all, who'd rather just kill them? Yeah? That's one for yes, another one, and a lot of no's. Who would rather change them so they can't transmit disease? Ooh, that's okay. This is a pretty overwhelming favourite in this audience. Change them so they can't transmit the disease. You don't mind being bitten. I guess they'd rather have them in the ecology, even if they're invasive species, which these ones mostly are, and make the sort of minimal change that just stops them doing the harm. Interesting. Answers vary one place to another. There's no right answer. There's no right answer. Okay. So another thing that we can do is say, well, this modification, how long will it stay in the environment? And there's a whole spectrum of possibilities. So those sort of sterile males that we mentioned, so if you release sterile males, mate with a female, she has no offspring because she mated a sterile male, but that modification disappears. If you stop releasing sterile males, it disappears from the environment really quickly. Over this end, it's very controllable, reversible, you stop releasing, it goes away, but you have to release a lot. These males don't live as long as a week, so you probably need to release them every week, maybe more often. You need to release a lot of them because you want most of the females to make your males. Over the other end of the spectrum, you could think about something that's highly invasive, that you release a few of them, and this genetic element spreads itself through the wild population through mating. It's going to be cheap because you don't need to release very many, cheap to deploy at least, maybe permanent or at least long-lasting. On the other hand, once you've released it, there's very little you can do to get it back. And you might imagine something in the middle in the middle ground. And the question is going to be, which of these would you prefer? But I'll just explain them a little bit more in a moment. So imagine you have a number of mosquito populations, like these are cities, let's say, and there's a certain amount of migration, or islands, if you like, in an archipelago, and there's a certain amount of migration from one to another. And if you release the mosquitoes into one of those populations, and then you stop releasing, what happens? And the number of possibilities. Okay? So over here, if this was like sterile males, something like that, the modification would just disappear and the mosquitoes would go back to normal. If you have a highly invasive genetic system, this little bit of migration is enough to get it into each of these populations, and over time, and probably not very much time, it'll spread through all of them. Or we could imagine something in between where it will establish in the population in which you released it, so whatever it does, whatever the control is, let's say, it doesn't transmit the disease anymore, it'll continue to do in this population, but it won't do it in any others. And these could be different countries, different cities, different whatever. So again, if we could do any of these, which would you prefer? So who's at the sort of cautious end of the spectrum? You don't mind spending the money to release a lot, but you want it reversible. Nobody. Ooh. What about this end of the spectrum? Release a few of them here, it'll spread through the whole population around the world, doing whatever it does. Yeah, got a few of those. And how about here, I'll treat my city, other people could look after themselves. I'm not going to interfere with them, but equally I'm not going to help them. They can do their own thing. Who would like this middle ground? Okay, so very roughly, I would say these two were about equal, and this one, which is what I spent maybe 20 years working on, less popular. Okay. I mean, we did this because we could. It does have advantages and disadvantages. They all have. There's no right answer. Each has advantages and disadvantages. This is harder from a regulatory point of view. Aedes aegypti is probably in 100 countries, and if this is going to go through all of them, can you get 100 countries to agree on this, or indeed anything else at all? Whereas these, you really only need this one area here to agree. So there are not just sort of technical scientific issues. There's a lot of regulatory and political and social issues that might guide your decision. And sort of related to this, if this class of systems, which are called genetic pest management, you might wonder, will anybody use them? This involves releasing large numbers of genetically modified mosquitoes into the wild, of species that are biting people, transmitting human diseases, and so on. So this is the mosquito, one of them, and this is what we do at the moment. And so these genetically modified mosquitoes, we mark them with fluorescent proteins so they glow in the dark. And so we can tell one from another. It's competing with vaccines or therapeutic drugs and so on. And which will people use? And the jury's still out on that. Which will people prefer? And different people in different places might have different answers. There aren't, as it happens, these are coming through. There are not good vaccines for dengue and some of these other diseases. And there are also no specific therapeutics either. So all of this side is a little bit hypothetical. This is what we do at the moment. But just to, in the final couple of slides, these are surveys in a project that we did. This was releasing large numbers of, over time we released over 1 billion, although not in this trial, of engineered sterile male, let's call them, mosquitoes. And this was the project. This was in Brazil. I have no Portuguese, but I think you'll see it pretty clear what the project was about, releasing transgenic Aedes mosquitoes. And in 2 different locations, this was a suburb, a city, it was a village outside, Brazilian scientists asked us a series of questions about the project, but I'll just draw your attention to this one. Do you want the project to continue with releases of genetically modified mosquitoes in this community? And in this trial, 97% and 98% said yes. Okay? So you clearly can get very high levels of approval for release of large numbers of genetically modified mosquitoes. That doesn't mean that every human community every time will want them, but at least some of them, some of the time, clearly do. And I should say these releases were highly successful, reducing the target populations by 90% or something like that as well. And I'll stop there. Thank you.